Hi everyone, we are Project 35 and we are excited to present our Java project, Rekoda. And as we go in depth with the details of this project, we would need to outline the capstone overview, what Rekoda aims to solve, and our approach, the architecture, design, and structures of our Java project. And finally, we will be doing a demo and the following steps that we'll be taking after. Sentience, which is our capstone project, is a Unity engine based game that centralizes on the theme of mental illness. The key feature, and also what sets Sentience apart from other RPG games, is that it utilizes speech emotion recognition, also known as SER. This speech emotion recognition is powered by Python and a library called scikit-learn. In a given scenario of this gameplay, the player can be prompted by the NPC, and in return, the SER script will determine whether the player's voice reflects either happy, sad, or neutral emotions. These classifications of emotions are then passed into our game and will reflect details such as the weather and other environmental factors. But like many projects, Sentience also has an underlying problem in terms of the accuracy of our SER script. This SER script is currently working with the result of 1,000 voice samples trained by scikit-learn, and this dataset gives us a 74% accuracy in determining the emotion classifications mentioned earlier. As a result, our gameplay can incorrectly reflect the changes in the weather and the environment. On the other hand, this can also be interpreted as a bug by the player. But with a talented development team, we can leverage our skills by building software that mitigates this problem. And Hano will be expanding more on our approach for this project.
So, in order to solve this problem, we decided to gather our own voice samples. So, we decided to create a web application that will promote our game, Sentience, and collect voice samples from voluntary participants to expand data sets for SCR Engine's machine learning. The voice samples from variety of people from different backgrounds will increase the accuracy of SCR Engine's result no matter who is playing this game. As the accuracy of the engine goes up, the gameplay will be significantly enhanced and will give us as developers more choices on branching out our story and creating unique interactions between the players and objects and NPCs. The process of collecting, storing, and manipulating the voice samples is as shown in this diagram. The user will approach our recording application, which was developed in Angular, Record RTC JavaScript library. A real-time communication for media data in the web is used to capture user sound input. This data is a blob, but we convert it to base64 in order to pass it over to Spring Boot, our backend framework, through recording service. When Spring Boot gets the mapping for saving the data, it will store the data in MongoDB and also save a WAV file of that audio in a folder directory. So at the left is the screenshot of MongoDB with 2 raw data of voice stored. When we call it back through Spring Boot to Angular, it will get passed as a recording entity, and its base64 will be converted to a file type of WAV and will utilize the file from there on. And this is our low-level wireframe. We wanted the recording button to be in the top center to grab the user's attention and for ease of use. Keeping that in mind, that's how we started building on top of this, and Han will go over the demo.
Alright, welcome everybody, and I hope you're ready because I'm very excited to showcase to you Project 35 Rekoda, a web application that can record and play back your voices, and these voice samples will be used towards training our speech motion recognition API for our game Sentience. And in order to do so, we've created 3 main components for our web application, simple enough: record, playlist, and sign in, all accessible via the nav link here. Alright, so the recording is our main components, and the buttons calls to actions to record also reside on the landing page, accessible via our logo here, team logo as well. And let me jump into the recordings right now. So click this button, you'll be able to see an audio visualizer that indicates that your voice is being recorded in real time. And this utilizes Web Audio API along with audio context from user microphone input or any other live data input stream you so choose. And this will be animated by JavaScript. And thanks to the Babel plugins from Node modules, it helps to transpile the Edge Java script into EX5 or EX6 JavaScript, allowing us to run this in any browser, even the older ones. Alright, so speaking of compatibility, Web Audio API is a built-in API for every website. So what we're showing here visually is only a part of what Web Audio API or the implementation of it is capable of. You can also use this to get user media and then dissect the voice samples or the audio to its frequency, pitch, and volumes. And that is why we have decided to use or utilize Web Audio API for our purpose and have it in our front end. And we have a small token of appreciation here as a message to everyone who lent your voice to the game. It really does matter. And if I stop my recordings right now, you will be able to immediately see your latest recording. You can play it back and click the button. You will be able to adjust the volume. An audio visualizer popped up. Right. You can also download it or adjust the playback speed if you so choose. And as I finish recordings in the back end, what it does is that the audio information or data is saved into our front end models, which is recording models with its ID, its exact date of being recorded, which I will show you later on, and the audio file itself in base64 string instead of WAV file, which takes a lot of storage space. So we've decided to use base64 instead. And as you can see here, it will be posted to our backend and saved it to MongoDB. As I search the playlist, all right, a little loading screen there for you if you're waiting. All right, so it's not taking much time at all since we use base64 string for saving the audio recordings. And as I've said before, we posted using our service recording service TypeScript, and this we also use this the service TypeScript we created for recordings to get all the data from our Spring Boot API upon initialize. So you'll be able to see all past record displayed here. Alright, so I have prepared two audios beforehand for demonstration purpose, showing you that a recording the day before is being registered properly here, and you can play it back. You can delete it if you want, or if you're not satisfied with the audio, and click the button, you will be able to see this is a new one. Sounds familiar? You can delete it if you don't feel like it's satisfactory. Alright? And it will update for you in real time. And the list here is left with only 2 recordings. And the delete function is also using a method from the service TypeScript as well to interact with our backend API. All right. let me jump into the sign in component now, where you can see the form for the user to fill in their informations, and this helps us to connect with you and help us to learn more about you, as well as you being able to learn about our game as well as our application Rekoda. And currently we're still estimating our server as well as the ability whether or not we can store the user login data as well, so we have yet to implement it, but in the future we're hoping to use OAuth 2 for Spring social logins for an even better selling experience or a smooth sailing experience in login. You can just use your social accounts and log in into our web page. Alright, you can sign in or sign up if you haven't have an account yet. And this is our future plans, and Omar can even expand it further on this topic, and I will be handing it to him and he will lead you through this topic. Alright, thank you for your listening.
So our next steps for our project are that currently we are storing these samples locally and they get deleted whenever our application stops running. To be able to store these clips, we want to be able to upload these to maybe an S3 bucket or an Azure disk storage. Security implementation will also allow the users to pick whether or not they want to submit their audio clips to us or delete the recording so that they don't get saved to our database. By having these clips stored, we can have them analyzed and output the emotion that our machine learning algorithm determines from these clips. Currently, Scikit only uses WAV files to determine on emotions, but using a codec will allow us to convert these audio files from a WAV file to a FLAC file. The only difference between FLAC and WAV is that FLAC is compressed, while WAV isn't. They're both lossless audio files, so we won't have any information lost in between them. One of our upcoming plans further down the line is to also implement TensorFlow. TensorFlow is a JavaScript library for training and deploying machine learning models in the browser and on Node.js. It can also be used with Google's Teachable Machine, which is a web tool to create machine learning models for our project and training our AI to recognize speech to improve the quality control of the voice sample upon recording. This is an example as to how TensorFlow.js bypasses the need for any backend to host or deploy our services. Here we are at the end of our presentation. We thank you for listening, and if you have any questions or comments, feel free to ask, and thank you for your time.